Hi everyone and welcome to this DCD talk. I'm James Raddings, Digital Portfolio Lead here at DCD, and today we'll be talking about national gas as a bridge to AI scale. I'm joined by Stiven Smith, who's Vice President of Power Generation, Natural Gas Prime Power and Microgrids over at Cummins. Thank you very much to Cummins for partnering with us for this talk. So Stiven, great to be with you. To kick things off, can you tell us a little bit more about your role at Cummins and what you're seeing in the data center power market today?
Sure. Thank you, James, for having me. Stiven Smith, as you said, I have been in this role for approximately 2 years, but I have extensive experience in the power generation, in the standby market, and most before of that in the rental. So I accumulate approximately 12 years of experience in the United States in the power generation side. I lead a group of people that our main mission is to solve the prime power needs, considering natural gas. Also, microgrid has a whole integrated con solar panels and also battery energy solution systems. Other technologies are emerging, and what I see is the 2 years ago it was like a toggle switch that the AI hyperscalers and colos, even including the engineers, decided to consider natural gas prime power for all the solutions.
Yeah. So AI is certainly the power mix has certainly evolved, and the demand for it is huge. And I mean, how has that kind of bottleneck changed the way that data centers are planned and built?
That's a good question. So back on the days, or still today, there is a segment of the market that is considering the power coming from the grid. Historically, all those developers basically selected a site based on fiber connectivity, line availability, tax incentive, and obviously access to the workforce. Today, the first question that they make to us is how quickly can I secure power? And when the grid tells them, oh, I need to wait between 5 to 7 years, which is kind of the average, they decided to take things into control. So now we are observing a trend that is more, okay, let's gonna secure power now, and later let's gonna connect to the grid. So the first question made is power, access to power.
Yeah, no, it's interesting how you say the kind of the script has been flipped a little bit, hasn't it? It's all well and good to get connectivity and obviously need the workforce, but if you can't switch it on, that's quite fundamental. With the development of on-site prime power solutions becoming quite important in the data center power strategy, how are you seeing that, and why is natural gas emerging as a key enabler to that as well?
Yeah, good question. So specifically for AI data centers, the workloads are fluctuating, are huge. So the power is needed at this moment, is now, not like I mentioned earlier, between 5 to 7 years. So the path to have success in AI data centers depend on how fast you can secure it and not depending on the utilities. So having a behind the meters response that where you can control your own power, that you can in this model or approach of bring your own power, where you can have control of that, you can decide when to turn it, you can decide how to maintain it, and it's scalable. It's paramount. So in the United States specifically, we're the fourth largest natural gas producer on the world. And not only that, but we also can extract it, compress it, transport it, and there is an extensive network across some states in the United States, not all of them, but there are obviously spots on that one. So it's a cheap, decently cheap fuel source at this very moment. And basically the technologies that are taking or converting this from molecule to the electron are basically reliable. So you have dispatchability, you have scalability, you have fuel availability, and obviously as you are talking to a Cummins employee, a Cummins representative now, it's a proven technology. It's not something experimental. It's something that has been tested. Even if you move a little bit beyond and you go to turbines, is also completely well known across the world, this kind of technology. So that's why the natural gas became the response to operate 24/7 and obviously respond to this particular need that we're observing at this moment.
Yeah, no, it makes sense. With the scale of these projects and the speed in which this whole industry is expanding, going for tried and tested techniques, and when you sat on all this power as well, it makes perfect sense. I saw recently that Cummins announced a new large megawatt natural gas platform. Could you tell us a bit more about what drove that investment and what customer challenges it's designed to address?
Yeah, well, Cummins is also pride of listening to the market, listening to the customer. So we saw the need, and we're a 100-year company at this moment, and obviously we already were doing natural gas prime power technology. So it's not something new to us. It's more about, like you said, the new platform. We're basically going to that 3.3 megawatt generator using the base of a proven HSK 78 to make it an HSK 130 has been announced already in the specialized media, like the recent announcement in West Texas with our partner Circe. So that's a continuation of our portfolio, just because we're listening to the market and understanding how it's going to evolve on the future. So this platform basically, first and foremost, is trying to speed to power and accelerate the deployment, since we need to move quick. And as I mentioned, we're using an existing platform just to scale it to a longer cylinder block, adding cylinder heads, but basically it's a proven technology. We're responding to the grid interconnection delays. This generator have the capacity to be scalable from hundreds of megawatts to potentially gigawatts at this very moment. So you have that flexibility with the footprint. And it's also respond to this requirement for AI workloads that I mentioned earlier, and you also mentioned in your question, that are eager for power. Also, the platform will allow quick integration to the microgrid, to the behind the meter request that we have receiving, and also have the capability to work in a parallel way with hybrid energy architectures. And well, more important than ever, in the 24/7 request, you need to have the ability to service a package like this one, and also looking for reliability, you need to have operational support. So that's another challenge. Going back to your question, to the core of your question, what challenges are facing that now? Maybe there are solutions, but the question that developers and architects need to have in mind is how you're going to keep those assets running for the 10 period of time that you're expecting, 15 years in some cases, before the grid catch up or get to the level that you want. You want to have a solution, but also a reliable solution. So in Cummins, we're answering those questions. We have an extensive network at this very moment of branches in every major city across the nation, in every single state. So in that way, we can leverage a proven natural gas technology with the ability to service it and maintain it for a long time to provide this answer to the market.
Yeah, and it really underpins the importance of it, because at DCD we have 10 channels. I primarily work on the investment and the cooling ones, and I mean, even in those conversations, investors are starting to think, let's invest in power. It's really becoming a gateway. And from the cooling perspective, people who for 20 years have only looked at cooling are starting to look at the power sources, and how you mentioned it earlier with the fluctuations of these AI loads. So having consistent power is really at the central of the central theme of the industry at the moment. So it sounds like a really good project that you've got up and running. Looking a little bit more about the future of data center power, do you see it being driven by a single technology, or do you see a more diverse mix of solutions?
Oh, I don't have any doubt in my mind. It's going to point out to a diversified energy portfolio. So we're learning every day. We're learning about AI loads.
Yeah.
And we see that the technology is going to evolve with optimizing the chips, optimizing how it's working. So at this very moment, we understand there are a base load we need to provide power for, and there are spikes in those AI requests from the chips. So this is too large. This is too large, and it is also evolving. So it's almost impossible that one single technology will be able to meet every single requirement. even today in the architecture that we're proposing to the customers. And going back to my initial idea that they wanted to secure power via natural gas, but later to answer the question, well, now how I can handle the load. The first answer is our batteries, the batteries that obviously are also in the Cummins portfolio. We're regulating the load using BESS or battery energy solution storage with the generators. In one real application, in one of the first-in-class deployments, we're combining those two technologies with turbines, natural gas turbines, in order to the turbines are managing a portion of the base load, generators take the second base state load, and batteries are handling the third and more fluctuating one. But we're also observing into the future that people and developers are asking questions about kinetic models, or a fancy name for flywheels. Also, supercapacitors are being considered to manage that, but also in the power generation, eventually we will be facing nuclear technologies. So it's a dynamic and evolving market. I think my point is, at this very moment, the natural gas are the response, along with turbines, battery energy solution storage. But in the future, we're observing a more diversification of those technologies. And my opinion is, especially in the behind the meter solution, I believe the winners are going to be people that can understand that can architecture that aspect to build a resilient solution that can be obviously economically attractive for those developers.
Yes, I mean, we've touched upon the underpinned the importance of, having that diversified power portfolio. How can operators be preparing for that today with the energy and power challenges for tomorrow?
Yeah, good question, James. Thank you for that. I don't mean to be an expert of the complete architecture by any means. I believe there are specialized companies on this segment, but I will see, based on what we're developing, Cummins is developing that, and all the technologies we're considering at this moment. My advice is to think beyond the immediate power needs. So the world is eager for that. This is a race for a reason. So my first is to secure power early. This is the first question asked as we go back to your very first question. So it's not about an engineering decision. We need to secure an energy pathway early in the career. So that's kind of my first advice. The second one is, once you secure the power, you need to consider the flexibility. We already discussed that we will face a future where AI demands is going to fluctuate, are going to evolve. So there should be the ability to escalate in the natural gas prime power movers and the combination with batteries, but also trying to design for flexibility. That's something that in Cummins we can use controls to basically, and switchgear basically to control that flexibility and help you with that. The third one is hybrid energy system. So it's a combination, a storage of the energy, what we call the power quality and power conditioning of the source is going to be important. So you need to be nimble how you manage those different aspects. So when you think about hybrid energy system, you are thinking about, hey, I'm becoming more resilient. I'm not depending on one source. I'm taking several of those resources and putting together in order to develop one. The last thing that I will say is don't lose sight of, once you have the asset, you need to maintain it and ensure that it's going to last the time that you define. So be sure that whenever you choose any kind of technology, you will have a company that will back you, that will be there for you, that will have all kind of parts, trained people that will take care of that aspect. I think those aspects, the four aspects that I mentioned, are going to be paramount for any company that will be trying to prepare for tomorrow's power demand.
Yeah, no, that sums it up perfectly. And yeah, like you say, first things first, secure power, have different types of solutions which support each other, and do that moving forward to secure this for the future. And at the rate that these things are growing, you can't afford to not have one eye on the future as well. Well, thank you so much for your time today, Stiven. It's always good to catch up with yourself and somebody from Cummins as well, because you guys are really at the forefront of all this stuff. Thank you to everyone for watching at home as well. If you do have any questions about anything myself or Stiven have discussed today, please do reach out to Stiven and the team over at Cummins. I'm sure they'll be very happy to hear from you. But thank you, Stiven, and thank you everyone for watching.
Thank you, James. Thank you for having me, and have a good day.